As you create a simple circuit, this PDF goes alongside with it to help you know some more details. I want to point out a couple things. One, AA batteries have 1.5 volts and typically 400 to 900 milliamps. Now we'll distinguish the volts between the milliamps later, but for now, just know the 1.5 volts. Another thing you need to realize are the jumper wires. And you'll see in the picture how some of them have a pointy end sticking out and some of them have more of a hole in them. And those are male and female jumper wires. They're a way for us to connect things together. To distinguish the difference, male has the end coming out and female has the hole going in. And that is what they are. In an LED, you'll notice there are two different links here. The longer end is the anode, which is the positive side, and then the shorter end is the negative, which is called the cathode. And LEDs are light emitting diodes, and it only works one direction. That's why it's so important that we put them in the right direction when we plug them in. Scroll down a little bit farther and see voltage and amperage. These terms are very similar together, and that's why it's very hard to know what they are. You'll see that kind of pointed out in the last sentence. When you combine voltage and amperage, the formulas together, you get wattage, the amount of current. One way to think of these two terms is like a waterfall. Voltage is a force that's going to push it down, and amps is the amount of water. Okay, so think of a waterfall. If we have two waterfalls, one's very wide and one's very narrow. Okay, now the rate at which those waterfalls, the amount of water going to the bottom could be the same. Okay, the amperage could be the same going through a system, but the waterfall that's really narrow is going to have a lot of force because the water is having to go through one spot. It's got a lot more pressure on it. But a waterfall that's really wide, even though it could have the same amount of water going over it, would be going slower. And so the difference there is voltage and amperage, and it's something that's just going to be hard to understand as you go through, but they're two terms that are related, but also a little different. Here I'll show you kind of on the PDF, just so for those visual people who need to see how it is built, battery holder to the LED. In this case, it's not connected. That's a simple circuit, or sorry, that's an open circuit, and electricity cannot flow through that because it's open. But in the next part, when you see that it's a closed circuit, the electricity can flow from this positive to negative circuit and go back and forth. You also notice the batteries. The two AA batteries are 1.5 volts each, so add those together and you get 3 volts, and that's how much is going through. I've said this before, I think, but the LED there is only rated for about 2.3 voltage, so that can burn that light out after a while, depending on the amount of amperage going through it. And this final page, this is a lot of important stuff. The part on the left there, devices with microcontrollers, are all sorts of things that have some sort of controller inside of them that make them work. The most common ones that we think of are like our microwave, for example. There's a screen on it. You don't unplug your microwave every time you use it. You can push the buttons and make it do what you need it to. Lots of different things, your PlayStation, your games, washers and dryers, and even your car. The car has about 60 of these microcontrollers in it to control different things. More specifics on the Arduino. It was invented in Italy just so that people could learn to program. And it's pretty affordable, about $30 depending on the version you get and the size. And it allows us to build things and also program them, which is why you're using it in school or you're learning how to use it. Because you get two sides. You don't just get programming or coding, but you also get to learn how to build the things, which is awesome. You need to realize these things are everywhere. If you've ever taken apart a device and you've seen like that green board in there, that circuit board, that's a microcontroller or a microprocessor, and these things are everywhere. The future is going to be made up of these things. One day there'll be drone delivered pizza, and that drone is going to have some sort of controller in it to make it work. Self-driving cars. They have self-driving cars already, but maybe soon we'll have cars that just park themselves. You can drop yourself at your house and it'll go park itself in a garage and even like hook itself up to a charger. I don't know about you, but the future is going to be made up of a lot of devices, and maybe you'll be the one to control it, or the one to program it, maybe the one to design it. So in this whole series, I'm teaching you how to program and how to build these things so that if you have an idea, if you imagine something already, you can make it a reality.